Alright, and in this last video, I'm going to cover pretty much the same idea, just slightly more complicated examples. And these are going to lead to what we know as quadratics, which means we're going to end up with things that have power of 2, and we're going to have to use different solution methods for that. So let's go ahead and get started with this one. So it is log base 6 of x squared plus 3x plus 18 equals 2. So the good news is this one is already condensed. In the first example, it wasn't condensed yet, so we had to do that part first before we could apply the loop-de-loop trick. But here, we're already ready to go. So I can go ahead and say with a base of 6 to a power of 2 is equal to all of this. So 6 to the second power is equal to x squared plus 3x plus 18. And if you remember from first semester, this is pretty much what we call a quadratic because it is power of 2. So this makes it a quadratic. And there are a couple ways to solve quadratics, but one of the first methods that I would try is what we call factoring. But before you factor, it's always a good idea to make sure that one side is equal to 0. And right now we see we have a pretty long trinomial on one side, and we have 6 squared, or what I'll just simplify as 36 on this side. So I think you'd agree with me that it's a little easier to move this 36 over here than it is to move all this junk over here. So let's go ahead and do minus 36. Minus 36, I'm putting it with its family member for like terms, and that'll go away, that'll be 0. X squared has no family member, 3x has no family member, and 18 minus 36 is negative 18. So at this point, you'll see that we have a quadratic, and the way that we have pretty much been solving the whole year is with what you guys have come to call the Xbox method. So in case you forgot the Xbox method, kind of looks like this. And if you remember, in the top, we put A times C above the clouds. And in the bottom, we put B, the basement, abajo, what else? What other things do we say? Below, bottom, etc. So where's your A, B, and C? Those are going to come from these numbers in front. So, oops. So this value is A, this value is B, and this value is C. So we have A, we have B, we have C. And A in this case is 1. So for A times C, it's going to be 1 times negative 18, which is negative 18. And for B, it's going to be 3. And the game that we play is what two numbers can I multiply to get the top? And those same two numbers add to get the bottom. And if you do a little bit of thinking, you should come up with 6 and minus 3. And if we go into our box, you may also remember we talked about the quiet little lion cubs. And we can go ahead and throw our quadratic piece in here. So that's going to be 1x squared. We can throw our constant at the end, and we can throw our linear pieces there. And then we just pretty much figure out what can we multiply to get the inside. So we're going to use the area model. So this would be 1x and 1x. 1x times 6 would give us 6x. 1x times minus 3, and we check it, and it does check out to negative 18. So that means that we can rewrite this trinomial as x plus 6, x minus 3. And that will actually give us two answers. This yields one answer. This gives another answer. So if we do, you might be pro at doing this in your head already, but I just want to remind you where this comes from. If we set both factors equal to 0, this will give us minus 6 as one of the possible answers. And if I add 3, this will give us 3 to one of the answers. So that would be how we would solve for these solutions here. I'll go ahead and check this one as well. So here we would do the exact same thing. Luckily the log is already condensed. So let me blow this up. We would take, so this one's a little weird because it has a whole expression as the base, which is not super common, but the logic is the same. So if we wanted to write this in exponential form, it would be, this is the base, this is the exponent, this is the answer. And so you can clearly see this is going to be exponential. So the thing with this part right here is we need to expand this. So we're going to do a quick little side X box over here. So this isn't the factoring X box. This is the, I want to figure out the expanded version of the left side. So this will be x squared, 6x, 6x, 36. And if we combine these two like terms right here, that will give us 12x. So this would be x squared plus 12x plus 36. So another way to write this side would be x squared plus 12x plus 36. And that's equal to 2x minus 9. So again, just like we set up here, whenever we're getting ready to factor a quadratic, we always would like one side to be 0. In our case right now, we have a really long trinomial, and we have a not much simpler, not much smaller binomial. It really doesn't matter which way you go. I'm probably going to suggest that you do whatever makes the most sense to you. For me, I like to make sure that the a, whatever the quadratic part is positive. So I'm going to move what might seem like more work for you. And then I'll just tag this part on the end because it doesn't have a like term. But I pretty much just canceled that whole side. So this will be 0 is equal to, this would be x squared, 1x squared. This would be negative 45. Notice I'm putting it at the end because those are constants, right? They have no variable. And I'm putting the negative 12x there. Now we are in a position to factor. So I'm going to put an x in a box. So I'll identify my A, my B, my C. So again, above the clouds, bottom. So A times C would be negative 45, B would be negative 12. And again, I have to do a little bit of thinking. Let me see, 45, 1 times 45, 2, 3, and 15. So I'm going to do negative 15, positive 3. Yeah, that works. Yay. So then I go quiet, little lion, cubs. So this will be 1x squared, negative 15x, 3x, negative 45. And I can very quickly factor this out. So 1x, negative 15, positive 3, and this checks out because those multiply. So my two factors are 1x minus 15 and 1x plus 3. And again, if you see very quickly, you can figure out the answer. X can be 15, or x can be negative 3. And that is pretty much how you do the quadratic ones as well.